Good morning, students. Today we will discuss the problems of continuity. Yesterday we discussed the continuity definition. Once again, I will repeat that continuity definition. Continuity. A function f of x is said to be continuous at x is equal to a if limit of x tends to a, f of x is equal to f of a. That means we have to prove limit value is equal to function value. Limit is exist means the perfect definition is limit x tends to a minus f of x is equal to limit x tends to a plus f of x is equal to f of a. This is the perfect definition of continuity. Left limit is equal to right limit is equal to, that is function value. So in this chapter, if you know how to solve the simple limits, it's enough over. You will get 4 marks question. Now on first problem, prove that exercise 5.1. Exercise 5.1. From this exercise, you will get 4 marks problem. See the first problem. Prove that the function f of x is equal to 5x minus of 3 is continuous at x is equal to 0, at x is equal to minus 3, and at x is equal to 5. See this one. F of x is equal to 5x minus of 3. It is a linear function. That means polynomial function. Any polynomial function, its domain is real numbers. So it is continuous on R. It is continuous on R. So it is continuous at x is equal to 0, at x is equal to minus 3, at x is equal to 5. 1 mark problem. Just note down. Given f of x is equal to 5x minus of 3. F of x is a linear function. Is a linear function. How to write the answer? Is a linear function. It is a linear function. So the domain of f of x is R, real number system. Any polynomial function, its domain is R. So that implies f of x is continuous at x is equal to 0. You can write directly at x is equal to 0, at x is equal to minus 3, and x is equal to 5. That is the answer. This is the reason. It is a linear function. Its domain is R. So it is continuous on R. So in real number system, we have 0, minus 3, and x is equal to 5. That's all. Simple problem. See the second problem. Examine the continuity of the function. Examine the continuity of the function. Second problem. Examine the continuity of the function. Examine the continuity of the function f of x is equal to 2x square minus of 1 at x is equal to 3. We will discuss the continuity of this function at x is equal to 3. Now on given f of x is equal to 2x square minus 1. Here 2 types of answers. Directly you can write. It is a quadratic function. So what is the domain of a quadratic polynomial? It is R. It is continuous on R. So it is continuous at x is equal to 3. One type of answer. One other type. First find the function value. We'll follow the definition here. Find the f of 3 value, function value. Second procedure. let f of x, f of 3 is equal to 2 into 3 square. 2 into 3 square minus of 1. 3 square means 9 into 2. 18 minus of 1, 17. Let it is equation 1. Function value is 17. Find the limit value. Limit of x tends to 3, f of x. Limit of x tends to 3, f of x. So limit of this is x tends to 3, 2x square minus of 1. Substitution limit. Put x is equal to 3. This is equal to, after applying the limit value, we should not write limit. Write the notes very carefully. So 2 into, this is 3 square minus of 1. So this is equal to 9 into 2, 18 minus of 1, 17. Equation 2. So here, see this one. F of 3 is equal to limit x tends to 3, f of x. Limit value is equal to function value. That implies at x is equal to 3, f of x is continuous. At x is equal to 3, f of x is continuous. By using the property, directly you can write the answer, or else we can use the procedure, no problem. Examine the following functions for continuity. Examine the following functions for continuity. Go on, first problem. Here points are not given. When points are not given, we have to discuss in its domain. Third main, first problem. F of x is equal to, examine the continuity of the f of x is equal to x minus of 5. Y is equal to x minus of 5. Straight line it is. So x minus 5 is a linear function. What is its domain is R. So it is continuous on R. No objection. Not on that. F of x is a linear function. Is a linear function. Is a linear function. So the domain of f of x is R. The domain of the f of x is R. So f of x is, that implies f of x is continuous on R. No objection. Straight line will get if you draw the graph. So the second problem. F of x is equal to 1 by x minus of 5. What is the difference between these two problems? This is a linear function. This is a rational function. It is a rational function. Denominator is x minus of 5. So when it is not defined, x minus of 5. See this one. When x minus of 5 is not equal to 0 strictly. So x is not equal to 5. So the domain of f of x is R minus of set 5. R minus of set 5. First find the domain. Afterwards we will discuss the continuity. The domain of f of x is equal to R minus of, eliminating this element. Denominator should not be 0. So f of x is continuous on R minus of set 5. No objection. Only graph will be disconnected at the point x is equal to 5. Remaining you will get straight line. See the third problem. See, f of x is equal to x square minus of 25 by x plus 5. X square minus of 25 by x plus 5. See, this is also a rational function like f of x by g of x. X square minus of 25, numerator always defined, denominator also always defined, but when denominator is 0, f of x by g of x is not defined. So take this one, x plus 5 is not equal to 0, applying this condition. So x is not equal to minus 5. So what is the domain of this rational function? The domain of f of x is r minus of minus 5. R minus of minus 5. The domain of this function. So write the answer. So f of x is continuous on r minus of minus 5. That's all. Now on D, third main D. F of x is equal to mod of x minus of 5. Mod function. What is the domain of mod function? R. For any x belongs to R, it is defined. Right, that the domain of f of x is R. The domain of f of x is R. So f of x is continuous on R. So f of x is continuous on R. So to solve all these 4 problems, you have to practice how to find the domain of the given functions. Elaborately we will discuss in function chapter all this type of functions, how to find the domains. Now on 4th problem. Prove that the function f of x is equal to x power n is continuous at x is equal to n. N is a positive integer. Simple problem, 4th one. Prove that the function f of x is equal to x power n where n is a positive integer. N is a positive integer, it is. N is a positive integer. That means z plus. At x is equal to n, prove that it is continuous. So x power n polynomial function, it is continuous in its domain R. So it is continuous at x is equal to n. That is one reason. Or else find the limit values. At x is equal to n, we will discuss the continuity. At x is equal to n. In 2 ways you can answer this problem. In 2 ways. One is x power n is a polynomial function. Any polynomial function is continuous on R. So it is continuous at x is equal to n. And see this one. First find the f of n value. What is f of n value? N power n. Let it is equation 1. Function value n power n. Find the limit value. Find the limit value. Limit of x tends to n f of x. That is limit of x tends to n x power n. That is n power n. What is your observation? From 1 and 2, limit value is equal to here f of n is equal to here f of n is equal to limit extends to n f of x. Write the final conclusion. So at x is equal to n, f of x is continuous. At x is equal to n, f of x is continuous. At x is equal to n, f of x is continuous. F of x is continuous. That's all. See the fifth problem. Fifth one. Here, read the question properly first. Is the function f is defined by f of x is given to us, given f of x is equal to x. What is the condition? If x value less than or equal to 1, and this is equal to 5 if x value greater than 1. This is the defined function. Function is given like this for you. So we have to discuss the continuity of this function at x is equal to 0, at x is equal to 1, and at x is equal to 2. First we will discuss at x is equal to 0. First, to try to understand this type of questions. Note down the real line first. Just analyzing this function. 0, this is 1. Now see this one. When x is less than or equal to, when x is less than or equal to 1, both, what is the function is given to you? X. When x is greater than 1, when x is strictly greater than 1, what is given to us? Function is 5. So at x is equal to 0, what is the function? First, the discussion is at x is equal to 0. At x is equal to 0, what is the function? F of x is x. We had to take x and we had to discuss the continuity. Next, at x is equal to 2, at x is equal to 1. At x is equal to 1, left neighborhood is x, right neighborhood is 5. And at x is equal to 2, one more. 3 points we have to discuss. At x is equal to 2, what is the function we have to take? 5. See this one. At x is equal to 0, x is a linear function. It is continuous. At x is equal to 1, we will discuss. We will find the left limit and right limit because function is different. At x is equal to 2, it is a constant function. It is continuous. Okay, one by one. First note down. At x is equal to 0. First note down. Given f of x is equal to x, if x value less than or equal to 1 is equal to 5, if x is greater than 1. So denoting on real line, at x is equal to 0, which function we have to take? X. F of x is equal to x function. In 2 ways. Function value, limit value you can find. Follow that one. We will practice the definition. What is f of 0? 0. Limit value. Limit extends to 0. F of x value x. Put x value 0, substitution limit. What is your observation? Function value 0, limit value 0. In 2 ways you can write the answer, no problem. So at x is equal to 0, at x is equal to 0, f of x is continuous. At x is equal to 0, f of x is continuous. Now we will discuss at x is equal to 1. See, at the point x is equal to 1. At x is equal to 1, listen to me. In the left neighborhood, the function is x. In the right neighborhood, the function is 5. When x is equal to 1, what is the function? X. So here you will get the clear definition. Function value, left limit and right limit. First find the function value. At x is equal to 1, what is f of x function is defined? X is equal to 1, less than or equal to 1, two conditions are there. The function is x. Find the f of 1 value. F of 1 is 1. So this is a function value. Function value. First complete the function value. Next find the left limit, LHL. Left limit. Limit x tends to 1 minus. X tends to 1 minus. 1 minus means left of the 1. What is the function we have to take? X. In the left neighborhood of the 1, for all these values x only. X less than 1, function is x. Find this one. X tends to 1 minus means it is not minus 1. Don't get confusion. It is not 1 minus, left neighborhood of the 1. Minus 1 is minus 1. 1 minus means just we are indicating left neighborhood of the 1 we are indicating as 1 minus. Left neighborhood as 1 as we are indicating as 1 minus. That's all. It is not minus 1. Equal to 1, nearer to 1 it is value. Put x value 1, 1 it is. Left limit value 2. As a learners in calculus, confusion for you. Right limit. Limit x tends to 1 plus. 1 plus means it is not plus 1 meaning. 1 plus means it is right neighborhood of the 1. In the right neighborhood of the 1, what is the function we have to take? 5. Limit of a constant. Yesterday we discussed. Limit of a constant. Constant. It is a constant. 5 is a fixed real number. It is a fixed constant. So limit of a constant 5 it is. So it is equation 3. So what is your observation? Left limit value is 1, function value 1, but right limit value 5. So LHL is not equal to RH. Limited does not exist. So there is no discussion about continuity. Right that. So at x is equal to 1. At x is equal to 1. F of x is discontinuous. If it is not continuous, it is discontinuous. At x is equal to 1, f of x is discontinuous. Third point, at x is equal to 2. This is first one completed. Second one, this is at x is equal to 1. Third one, at x is equal to, at x is equal to 2. F of x is equal to 5. F of x is equal to 5. It is 5 is a constant function. So it is continuous at x is equal to 2. Because any constant function is continuous on R. Right that. F of x is a continuous function, constant function. Is a constant function. Is a constant function. So it is continuous at x is equal to 2. So it is continuous. So it is continuous at x is equal to 2. That's all. Just analyzing these simple problems, you will get the clarity of the continuity. First, at x is equal to 0, x function it is continuous, and at x is equal to 2 it is constant function, it is continuous. But at x is equal to 1, left neighborhood is defined as x, right neighborhood is defined as 5. So left limit we got 1, right limit we got 5. So LHL is not equal to RHL. So at x is equal to 1 it is discontinuous. It is discontinuous. So by using these questions you can perfect the definition of continuity. Now see the important problems. Find all the points of the discontinuity of the f where f is defined by. We'll discuss we have to find the points of discontinuity. So first we'll discuss the continuity. We can find the points of discontinuity. Note on the first problem here. So the sixth problem. Given f of x is equal to, first note down the given function. Given f of x is equal to, given f of x is equal to 2x plus 3, a linear function, when x value less than or equal to 2, and this is equal to 2x minus of 3, 2x minus of 3, if x value greater than 2. If x value greater than 2. So denoting this line on real line, 0, 1, 2, when x value less than or equal to 2, what is the function? 2x plus 3m it is. When x value less than or equal to 2, the function is 2x plus 3. When x value greater than 2, when x value greater than 2, in the right neighborhood of the 2, the function is 2x minus 3. The function is 2x minus of 3. The function is 2x minus of 3. So we have to find the points of discontinuity. We'll see. When x value less than 2, first we'll discuss when strictly x less than 2, linear function, it is continuous. It is continuous up to minus infinity. It is continuous. When x value greater than 2, function is 2x minus 3. It is also continuous. Only doubt at x is equal to 2. So first clear those points. When x value, first condition, when x value less than 2, f of x is equal to 2x plus 3 is continuous. Is continuous up to, for x less than 2, it is continuous. When x value greater than 2, second condition, when x value greater than 2, how to write the answers, confusion for you. So based on the conditions, write the answers. When x is less than 2, f of x is equal to 2x plus 3. It is a linear function. You can write directly, E is continuous. When x greater than 2, f of x is equal to 2x minus 3. This is also continuous. Where it is continuous? The condition x greater than 2. For x less than 2, it is continuous. So where is the doubt we have still? At x is equal to 2. So we'll discuss the remaining and we'll give the final conclusion. At x is equal to 2, we'll discuss the continuity. At x is equal to 2, what is f of x function value? At x is equal to 2, what is f of x? X less than or equal to 2, we have to use which function? So at x is equal to 2, f of x is equal to 2x plus 3. Find the function value, f of 2. F of 2, 2 into 2 plus 3, 4 plus 3, 7 it is. So function value is 7. Let it is equation 1. Function value is equation 1. So find the next left limit, LHL value. Left limit, limit x tends to 2 minus. Limit x tends to 2 minus. 2 minus means left of the 2. Left neighborhood of the 2, what is the function? 2x plus 3. Evaluate this limit. Substitution limit it is. Linear function, substitution limit. 2 minus means it is not minus 2. 2 minus means left of the 2. 1.99999. Answer. 2x plus 3. 2 into 2 plus 3. This is also 7. Equation number 2. Find the right limit. Find the right limit value. Limit x tends to 2 plus. Limit x tends to 2 plus. 2 plus means right neighborhood of the 2. What is right neighborhood of the 2 function? 2x minus 3. 2x minus 3. 2x minus of 3. Applying 2. 2 into 2. 4 minus of 3. It is 1. Equation 3. LHL is not equal to, LHL value is not equal to RHL. That means limit does not exist. That means f of x is discontinuous at x is equal to 2. F of x is discontinuous at x is equal to 2. Discontinuous at x is equal to 2. That's all. That is the point of discontinuity. What is the point of discontinuity? Only one point. Only one point. That is 2. That's all. Find the points of discontinuity. Find all the points of the discontinuity of the given function. That is the question. Complete yourself 7th problem like this. 7th problem. Given f of x is equal to, given f of x is equal to mod x plus 3, the condition is x value less than or equal to minus 3. This is equal to minus of 2x when minus 3 less than x less than 3. This is equal to 6x plus 2, 6x plus 2 if x value greater than or equal to 3. We have to find the points of discontinuity. First, analyzing the given function. Answers are very simple. So how you will understand the function, that is important here. On real line, not on one real line. So 0, 1, 2, 3, left side minus 1, minus 2, minus 3. So the first one, x less than or equal to condition. When x less than or equal to minus 3, the function is mod x plus 3. In between minus 3 and 3, the function is, in between minus 3 and 3, the function is minus 2x. When x value greater than or equal to 3, x value greater than or equal to 3, the function is 6x plus 2. So in different neighborhoods, how the function is defined, note down first. Now listen to me. What is your observation? When x is less than or equal to minus 3, mod x is continuous on R, 3 is continuous on R, so f of x plus g of x is continuous on R. It is continuous up to minus infinity. No objection. It is continuous. Next, in between minus 3 and 3, minus 2x, linear function. Linear function always continuous. It is also continuous in between minus 3 to 3. Next, when x value greater than 3, 6x plus 2 linear function, it is also continuous. Only we have doubt at 2 points. One is at minus 3, another one is x is equal to 3. First write the conclusion one by one. When x value strictly less than, minus 3, f of x is equal to mod x plus 3 is continuous, because mod x is continuous on R, 3 constant function continuous on R, so f of x plus g of x is continuous on R. So this is continuous, no doubt, no objection. When x value is strictly less than minus 3, it is continuous. When minus 3 less than x is less than 3, what is f of x? Minus 2x is also continuous. It is a linear function, is continuous. Is continuous. When x value greater than 3, strictly, when x value greater than 3, what is f of x? What is f of x? 6x plus 2. 6x plus 2 is continuous, no objection. It is a linear function. Any linear function is continuous on R. So now at 2 points we will discuss the continuity of this problem. Note down. First, at x is equal to minus 3. Find the function value. Find the function value, left limit and right limit. So first we will see at x is equal to minus 3. Minus 3. Write the f of x. F of x is equal to function we had to write. See this one. Less than or equal to condition. Which function we have to take? Mod x plus 3. Find the f of minus 3. F of minus 3 value, function value first. Mod of minus 3 plus 3. Mod of minus 3 plus 3. Mod of minus 3 value, always 3. 3 plus 3, it is 6. Let it is equation 1. F of minus 3 value, 6. Function value 6. Find the left limit. Left limit amount. Limit x tends to minus 3 minus. Minus 3 minus and left neighborhood of the minus 3. The function is mod x plus 3. Find this limit. Put x value minus 3. Mod of minus 3 plus 3. This is 3 plus 3. This is also 6. Equation number 2. Find the right limit. Find the right limit value. Limit x tends to minus 3 plus. Right neighborhood of the minus 3. The problem is minus 2x. Minus 2x it is. So applying the limit. Minus 2 into minus 3m. This is also 6. So what is your observation here? F of minus 3 is equal to left limit is equal to right limit. All the three values equal. So what we can write? At x is equal to minus 3, f of x is continuous. At x is equal to minus 3, f of x is continuous. Is continuous. One more point. Still we have to decide at x is equal to 3. At x is equal to 3. What is the function? F of x is equal to 6x plus 2. 6x plus 2. F of x is equal to 6x plus 2. Find the f of 3 value. In this case, what is f of 3 value? 6 into 3 plus 2. 18 plus 2, 20. Function value 20. Let it is equation 1. In this case, find the left limit value. LHL is equal to limit of x tends to 3 minus left neighborhood is minus 2x. Applying it, minus 2 into 3 minus of 6. Equation 2 over here only. Function value is not equal to left limit. We can say discontinuous. Find the right limit also. Just practice it. Right limit is limit x tends to 3 plus the function is 6x plus 2. 6 into 3 plus 2 it is. So 18 plus 2, 20 it is. Let it is equation 3. So here LHL is not equal to RHL. Write that one. F of x is discontinuous at x is equal to 3. So what is the point of discontinuity for this total problem? Only 3. This is point of discontinuity. That's all. Find the points of discontinuity means already we proved it is. Write that one. So at x is equal to 3, f of x is discontinuous. Is discontinuous. That's all. It is a point of discontinuity. Now complete remaining simple problems in the same model. Eight, 9, 10, 11, 12, same models. I will finish the 8th problem, remaining do the homework. Here not an 8th problem. 8th problem. Given f of x is equal to, given f of x is equal to, given f of x is equal to mod x by x. Mod x by x, the condition is x not equal to 0. Equal to 0. Equal to 0 if x is equal to 0. Function is defined like this. Given f of x is equal to mod x by x when x not equal to 0 and equal to 0 when x is equal to 0. See how to define this function. At 0, 0, clear answer. When x not equal to 0, both in left and right, function is mod x by x. See this one. When x value left of the 0 always x less than 0. When x less than 0, what is mod x? F of x is equal to mod x by x. So what is mod x value? Mod x is equal to minus of x. When x less than 0 definition, minus of x by x and it is minus 1. So when x less than 0, the function we have to take, what function we have to take? Minus 1. When x greater than 0, see this one, right side. When x greater than 0, f of x is equal to mod x by x. When x not equal to 0, right side also function same. When x greater than 0, what is mod x value? X. X by x means 1. So when x is less than 0, what is the answer we have to use? Minus 1. Function is minus 1. When x greater than 0, function is 1. Define this function first. When x value less than 0, f of x is equal to mod x by x, minus of x by x minus 1. When x value greater than 0, f of x is equal to mod x by x that is 1. Now see this one. When x less than 0, minus 1, constant function, it is continuous. When x greater than 0, constant function, it is continuous. Only doubt at x is equal to 0. First write that conclusion. Strictly when x less than 0, when x value less than 0, f of x is equal to minus of 1 is continuous. Is continuous. No objection. It is a constant function. Any constant function is always continuous on R. When x value greater than 0, second condition, f of x is equal to 1 is continuous. Is continuous. Is continuous. So now we'll discuss that x is equal to 0. At x is equal to 0, at x is equal to 0, what is given to you? F of x value 0. Directly given, x is equal to 0, 0 function value. F of 0 is 0. So let it is equation 1. F of 0, 0. Function value 0. Find the left limit. LHL value is, LHL is equal to limit of x tends to 0 minus. Left of the 0, what is the function we defined? Minus 1. It is minus 1. So answer is minus 1. Limit of a constant. Limit of a constant, always constant. Limit of a constant, minus 1. So minus 1 it is. Let it is equation 2. Left limit value 2. Find the right limit. Find the right limit. So limit of x tends to 0 plus. X tends to 0 plus 1. That is equal to 1. It is equation 3. Left limit is not equal to, left limit is not equal to right limit. So at x is equal to 0, f of x is discontinuous. That is the point of discontinuity. What is the point of discontinuity in this case? 0. At x is equal to 0, f of x is discontinuous. That's all. That is the point of discontinuity. Ninth problem, same model. Complete ninth also. Remaining 3 you can do homework, simple problems. Not a ninth problem. Given f of x is equal to so the ninth problem, same model. Given f of x is equal to x by mod x when x value less than 0, strictly less than 0 condition. And this is equal to minus 1. This is equal to minus 1 when x value greater than or equal to 0. In both the conditions, x greater than or equal to 0, greater than 0, equal to 0, minus 1 we have to use. So first analyzing this function on the real line. So x is equal to 0 when x value less than 0. When x value less than 0, what is given to us? X by mod x. F of x is equal to x by mod x. When x value less than 0, what is mod x value? Minus of x. Minus of x, x cancel, minus of 1. So when x value less than 0, the answer is minus 1. When x value greater than or equal to 0, minus 1 it is. When x value greater than or equal to 0, it is minus 1. Now listen to me. When x value less than 0, minus 1 is continuous. It is a constant function. E is continuous. When x value greater than 0, minus 1, constant function is continuous. Only doubt at x is equal to 0. Left neighborhood is different, right neighborhood is different. We'll discuss that one. Okay? Write the conclusion first. When x is less than 0, f of x is equal to minus of 1 is continuous. Is continuous. When x is greater than 0, f of x is equal to minus of 1. This is also continuous, no objection. Constant function. Constant function domain is R, it is continuous on R. So we'll discuss at x is equal to 0 now. At x is equal to 0. What is f of x defined? F of x is equal to minus 1. So f of 0 is minus 1. Let it is equation 1. Function value minus 1. Find the left limit and right limit. Left limit value. Limit extends to 0 minus left of the 0. The function is minus 1. So limit of a constant. Right limit extends to 0 plus minus 1. It is in the right neighborhood also minus 1. Answer is minus 1. Let it is equation 2 and 3. So what is your observation? Here f of 0 is equal to LHL is equal to RHL. So at x is equal to 0, f of x is continuous. Write that one. At x is equal to 0, f of x is continuous. That means, see, when x value less than 0, it is continuous. When x value greater than 0, it is continuous. At x is equal to 0 also it is continuous. So there is no point of discontinuity. Not for f of x, there is no point of discontinuity. Null set term. It is continuous on R. 10, 11, 12, very simple problems. Complete yourself. Not on 13th problem. The function f of x is defined by is a continuous function. This is also simple. Try yourself. 13th problem. Is the function defined by f of x is equal to 10, 11, 12, do the homework. Simple, same model. Homework. 10, 11, 12. Do the 10, 11, 12 as homework. See the similar type of, is the function defined by, what is the given function? Note down first. Given f of x is equal to x plus 5 when x value less than or equal to 1. This is equal to x minus half 5 when x value greater than 1. E is a continuous function. We'll decide. See, x is equal to, this is 0, 1. When x value less than 1 or equal to 1, what is the given function for you? X plus 5. When x value greater than 1, what is the given function for you? X minus half 5. See the discussion here. When x less than 1, x plus 5 linear function, it is continuous. When x greater than 1, x minus 5 linear function, it is continuous. Only doubt at x is equal to 1. First write that conclusion. When x less than 1, first condition. When x less than 1, f of x is equal to x plus 5 is continuous. It is a linear function. Is continuous. When x value greater than 1, f of x is equal to x minus of 5 is continuous. Is continuous. Now we'll discuss the continuity at x is equal to 1. 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 What is f of x function? X plus 5. F of x is equal to x plus 5. Find the f of 1 value. F of 1 is equal to 1 plus 5. It is 6. Function value 6. See the left limit. Left limit. Limit extends to 1 minus. 1 minus. Left of the 1, the function is x plus 5. This is also 1 plus 5, 6. Left limit value 6. Find the right limit value. Find the right limit value. Limit extends to 1 plus x minus of 5 function. X minus of 5. So 1 minus of 5 limit value. Substitution limit it is. 1 minus of 5 means minus 4. What is your observation? LHL is not equal to RHL. So f of x is discontinuous at x is equal to 1. That's all. We proved x less than 1 continuous, x greater than 1 it is continuous, but at x is equal to 1 it is discontinuous. Right, that one. So at x is equal to 1, f of x is discontinuous. Is discontinuous. So tomorrow we'll discuss the remaining problems. Today after 12 o'clock I will release the question paper for you. So at your convenient time, honestly write the answers for those questions and check yourself. And if you are failing, once again practice that chapter. Okay, all the best.